Whoa. Yeah, draft science video. Thank you. Yeah. I think I'll deal with some more of the comments and such, but the one comment. But first, yeah, I was reading a page I got linked to, and it was sort of interesting. I mean, it was a lot of bullshit, but I mean, at the end, they just pointed out that you can see single slit diffraction just by putting your fingers together in front of a good light source, and the screen it works really well, and works even better if you put something over one of your eyes. Just use one eye. But you get these little gray lines, which are the destructive interference per se, as it's called. And so I've been messing around with different things. I had some of these whatever these little the flossing tool thingies. Yeah, I've learned how to do this. Anyway, when I put them together, the weird thing was that when they were touching, because of this thin little air edge they have, well, I got really, really clear, a whole bunch of lines, like 10 lines, and they were actually touching. I mean, there's actually, the lines went right through the part that touches. It was just, and you could move it anywhere, and the lines would stay exactly where they were, which is also unusual, because when you use your fingers, the lines change based on where you move your fingers. But like I said, you can really zoom in, which changes this whole idea of the distances that are used with this usual two-slit experiment or even single-slit diffraction. There's usually these great distances involved, and here the focal plane is very narrow, and yet there's still this pattern. It's also curious that there's no color shift or anything. I mean, I'm using like the white light off the monitor, and technically you would think there would be some color shift, and there isn't any. But that might have to do with the narrow focus, the narrow focal length. Well, anyway, it is just awfully curious to imagine that there's this pattern that, that goes wide and goes narrow. That it's being projected to both plane, both. It's sort of what I said the other day about the idea that the pattern is inside the pattern is inside the pattern. That appears to be more. This sort of kind of confirms that, I think. I have to play with it in my mind and figure out what it all means, but it is awfully curious. And it almost looks, it looks more and more like a field thing. It looks so much like like the edge of your finger has a field around it, and that's where the diffraction is taking place. It's just how it's appearing. It just seems that way. Seems very curious, anyway. And the idea too that if I use just one finger, all you see is that fuzzy field. You can sort of see a couple of little lines, but they're not as easily distinguished. And when you put the two fingers together, it becomes so much more obvious. Well, that's the other thing too. They don't have to be right apart from each other, but they just become, the contrast is increased. So it's like you can tell they're there, and that when they go across each other, it's almost like polarization. You can see them interfere with each other. You can literally see it. You can see the change as I move these fingers apart and move them across each other. You can see the contrast pop out, pop, disappear, pop out, just like polarization, just like turning polarized filters. So I don't know what to make of it yet. I haven't been able to run it through my head. I'm a little irritated that I'm spending so much time on this. because I don't know whether it's going to be that fruitful. But you know, the two-slit experiment is the most famous one, so it is a good one to argue with. But the very idea, like, you know, I don't know whether Newton ever wrote about it. I mean, the very idea that you can see these, you know, you don't see the, it's different in the sense that you're not seeing the strong central maxima, you know, very well at all. You're just seeing the destructive interference so much clearer. And the lines seem very proportional in terms of their spacing almost. I wish I could get the effect to happen with the camera. I haven't been able to get the camera to duplicate what my eye is seeing. So I have to work on lensing or whatever is required to try to make that happen. Maybe a macro lens will work. I don't know. Haven't tried that yet. So I'm just surprised that it was that easy to see diffraction. You know, just by putting, you know, I was using my thumbs were kind of good. But yeah, I don't know. This probably is better even. Is this, you can really see where the overlap is. You can see where the two concave shapes cross each other, and that's when the contrast, you know, the shape is already there, and it just makes it so much more visible. Yeah, so it does have this element of a sense of polarization to it, which has a sense of charge being associated with this. It just seems like that's a more, it's more in the ballpark as an explanation. Is that these are the diffraction pattern is a reflection of field lines, you know, around all matter. So I guess that's it. That's all the new thing I had, I think. I don't think there's any other new observation. You know, I was watching some more Feynman, and, you know, the stuff I've seen before, but I'm just going over it. And, you know, he said some really snarky things about Newton, which is just kind of funny, considering how much heat I get for saying snarky things about Feynman. You know, it's just kind of funny. But, you know, funny in the negative kind of funny way. I knew that would happen. One of my predictions. So anyway, I did an Inmendum video where I did respond to most of the comments from this one guy, and I just figured I'll do some more of it just to finish it up. And you know, Mr. Sock, John Sock, Suck. So anyway, some guy called Gobbledygook. It sort of sounds like an Inmendumism, but anyway, made some statement defending this asshole in a way. You know, defending in any way some idea that he's just asking for practical results or something. And I'm just that, no, you don't ask theoretical physicists what their practical results are. You know, unless you're going to ask a liar like, you know, Michio Kaku, who thinks, you know, somehow quantum mechanics did everything in all of human history of any merit. You know, it's really quite irritating when people talk like this invented that, and it really didn't. Even the transistor wasn't invented by quantum mechanics. It was invented by necessity. The only thing they had no way to regulate voltages without using mechanical switches. And essentially tubes, you know, the old tubes, were you know, almost as bad as a mechanical switch. I mean, they were just horribly wasteful. They got hot. They burned up. You know, there was a terrible way to regulate voltage. And so there was a huge incentive to come up with some solid state, some other way to use a small voltage to control a large voltage. So, and that necessity was what created the transistor. It's just, everybody was researching all kinds of, like Edison, they were, you know, smearing dog dew on cat fur and seeing if that would work. They were trying everything and anything to come up with something better than tubes to regulate voltages. But anyway, but history will just get rewritten by these assholes, and they'll pretend that if it wasn't for quantum mechanics, they would have never invented the transistor, which is just nonsense. But anyway, and again, separating quantum mechanics from interpretations that involve many worlds or Copenhagen or all that shit. None of that shit has any practical results, and that's what I'm arguing with substantially, a lot of that shit. And certainly you're not going to find any practical results in knowing how much gravity there is in space 10 billion light years away from here. I mean, knowing that answer isn't necessarily going to be very practical. Knowing how a black hole functions isn't going to have a lot of practical application. The point is what's the fucking truth? And that's what I'm arguing. I'm arguing, what does the evidence really point to? What is a more reasonable theory of the mechanics of existence in this material universe? And I'm saying, and I'm defending a theory that I think is profoundly more sensible than idiotic notions of photons lost in space who don't know where they are and who spontaneously decide to go somewhere and empty space that tells matter what to do. This space bends and tells the matter what to do. Come on. Anyway, people just suck. Alright, so I'll just be a little redundant. Either way, whatever you think of their experiments is completely irrelevant. I mean, even that premise is just so stupid. I've made real arguments about the fact that it's not just that what I think of their experiments, is what I think of their interpretation of the experiments, and the fact that they're lying about what the experimental results are. You can do single slit refraction with your own damn fingers, for fuck's sake. It's a reality. And for them to describe the two-slit experiment and not acknowledge that photons will not go through a single slit undiffracted is just bogus. Completely irrelevant with regard to you doing practical work based on your pre-scientific hypothesis. Well, again, the practical work is finding the truth, and that to me is a definition of practical, is the truth is important always. And beyond that, there's a practicality to not being an unrealistic asshole. So I'm saying quantum computing will not happen. Okay, you might have nano computing, but you will not have quantum computing. There is no spooky action at a distance, and there is no shortcut to the question 2 + 2. You actually have to do the math. There's no shortcut to answers. The promise of your wormholes to, getting to the other side of the atom faster than the speed of light or some other kind of bullshit is just that bullshit. Alright, regarding you doing practical work based on your pre-scientific, even if you could develop it into a scientific theory without the ability to use it to predict future observations, it's useless. Well, again, you say it's useless. I don't think the truth is useless. But clearly, I think the fact that I am explaining, I've already been through this, but I mean, it's relevant to the fact that there is absolute velocity. It's relevant to the fact that time dilation has nothing to do with time dilating. It has to do with the metabolism of matter slowing down. These are important facts of reality, and they will have significance. And they do have, I think, in terms of where we invest money. They're investing money in particle accelerators. Well, they ought to call them alchemy machines, because that's what they're really doing. They're converting matter from matter into energy. They ought to just call them energy releasers or something. They don't even understand the factual, practical fact of what they're doing. They're not smashing matter into matter, they're smashing energy into energy. Not to mention that a good scientific theory is potentially falsifiable. And again, what I'm arguing is falsifiable, as I've explained before. I'm saying that it really isn't practically possible for light to be affected by gravity. So it's falsifiable. If you can bend light with gravity, then you falsified it. Or falsified part of it anyway. It's certainly falsifiable in the sense that let's see. I mean, it will be. There will be a more extensive description of a reality here. But I mean, the fact that kinetic gravity explains so much. I'm just saying you can falsify it by coming up with something that it not only can't explain, but something that exists that it can in no way account for. And as I've argued in many videos previously, the easiest way to falsify any theory is to come up with a better straight line, to come up with a better theory. So everything is God is falsifiable by evolution. Evolution is a more reasonable, sensible theory. So it's the Occam-Razor thing. You go with the answer that's more complete and more simple. And if so, all you have to do to falsify me is come up with a simpler, better answer. And frankly, quantum mechanics, in the theoretical sense of Heisenberg and the rest of that crap, and space telling matter what to do, that is, in my opinion, the easy to falsify theory. It's not the simpler answer, it's the sillier answer. Your assertions have no factual foundation. Well, I just explained their factual foundation. It's a fact that there's single-slit diffraction. So you're just a liar. I mean, this is just an idiotic thing to say. It's a fact. And my assertion is for them not to include that fact in their presentation is a distortion and a perversion of the truth, deliberately engineered, in my opinion, to make it sound like there's a mystery. It wouldn't be a mystery anymore, right? It's like a magician wearing long sleeves, right? Well, yeah, if he can't wear long sleeves, then, yeah, where's he going to hide the pigeons? So with a single slit diffraction, it's a lot harder. Thunder. I saw the lightning. I thought it was just a flash. Yeah, that was a loud one. That was like a bomb or something. Fuck. What was that? Power will probably go out now. It's still rumbling on. That was really a good one. I can hear the rain. Probably got ice in it or something. Anyway, your assertion, yeah, if I can hear it, because I'm deaf as fucking the three blind mice. I don't know. I'm deaf as whatever the famous deaf thing is. I'm deaf as that. All right. Your assertions have no factual foundation. I.e., just saying that particles orbit at the speed of light doesn't make it true. And I don't just say it. So again, you just keep saying I just say it. I don't just say it. I explain it in the context of an explanation of how force is conveyed from one thing to another thing. Is the fact that this energy is constantly passing through things, carrying some information as it does that. It's being changed in its direction. It's going some new place. In that new place, it's a surprise when it gets there. It changes its balance. It's another, I could even bring up the thing about velocity, which is very curious. Because when you think about what velocity means, like to collect velocity, for something to acquire velocity, means that you have to keep filtering a specific kind. You have to keep collecting things that have a specific kind of imbalance, an imbalance of arrows going in one direction. So for me to acquire velocity, I have to keep collecting matter that's either going that way, and so a bigger and bigger percentage of my matter ends up being arrows going that way, or some force has to convey those arrows to me, has to give them to me by impacting me. Um, and that's not easy to do when you think about it. You just float, you're sitting in the universe. How do you acquire all this imbalance in a pressure field of perpetual chaos? Not perpetual, but substantial, let's say, call it, where the pressure is so even. Um, and it's not that easy to do. You really do have to collect a bunch of stuff that got shot out of a supernova, and it all has to be somehow going in the same direction. You know, it's not easy. But anyway, so high velocity isn't easy to acquire. I mean, I'm talking about high in the terms of from relative to the speed of light. Nothing's going, you know, very close to that. Anyway, that's in normal gravity. Something in less than normal gravity may well do that. Just saying, the speed like this doesn't make. Okay, so again, I don't just say it. I argue in defense of it as an explanation that makes a hell of a lot more sense than, oh yeah, light goes into an atom and it's turned into a shirt and then it's hung up in the closet. I mean, the counter theory is nothing. I think my theory is the something that is my theory is a hell of a lot better than the nothing the standard model gives us, which is nothing. It doesn't say anything about what the light does. It's just kind of eaten, and there's no explanation of how it's consumed, how it's digested by the electron. You can't argue physics. I don't know what that means. You can only experimentally demonstrate things. Well, that's idiotic. You demonstrate things with logical proofs just as well as physical ones. That's what thought experiments are and all of that stuff. So you're insulting Einstein by saying you have to do the experiment. No, all you have to do is present the paradox of the theory. And there's a certain paradox in the space. The nothing is telling the something what to do. That doesn't sound right. Looking for an all-consuming truth is a fool's errand. I mean, that's just such a stupid thing to say, in my opinion. When you consider how far we've come, you know, stupid monkeys. We've developed science. We've developed an understanding of collecting data and information and understanding mechanics and building machines. Where's the fool's errand in that? This all-consuming truth is just going to be a simple truth like evolution. Do you think evolution was a fool's errand? Understanding our origins and the machinery of evolution that produced us, the DNA molecule. There's nothing foolish in that. You're the fool who thinks there's no answers, who thinks there's an unknown sitting out there that we can't know. We can't know the truth. Ooh. And you're just saying it. You don't have any evidence of it. You don't have anything rational to put up as proof of it. You just say it. No, you're just a despicable creature. Yeah. Anyway. So yeah, I you know, fuck off, as they say. You can post comments, but I'm likely to delete them if they continue just to be rude, obnoxious piles of shit. You're not counter-arguing anything at all. Not a single assertion I've made, not a single argument I've made. You haven't counter-argued them at all. No, and that's really critical. I mean, you can't, you can't say something didn't happen and provide no evidence that it didn't happen and provide no evidence of what did happen. You have to do one or the other. You either have to show how it couldn't have happened, or you have to show how this other thing did happen. And you're not willing to do either one. You lame, lazy, rude, dickless asshole. Okay, I think that's enough. So anyway, yeah, so much to ponder. Yeah, really is. So yeah. And so it's, again, just one of these little curious things, with this whole, you know, putting your fingers together thing, and the idea that you see that darkening happen, you see all kinds of things, and it's almost like the you also see it's like almost like there's a carrier. You almost see like one finger is dominant over the other one in terms of the creation of the pattern, which is also curious. So I just got a little bit of moisture in my finger. It didn't work. That's interesting. It doesn't work as well. Wow. Works very different. I get a whole different kind of pattern now. It's like the two merge at that central point. That's another field kind of thing. But it's like when I do this, I can sort of see the top one is dipping into the other one. It's like it's like it has dominance for some reason. And now the bottom one has the dominance. That's very curious. You see, as I lower the one finger into the other, it's like you can see the two outlines, the two hazy outlines. And as I run the two together, it's just like polarization. All of a sudden, there's this contrast enhancement, and I can see the interference lines begin to appear very strongly, where they were very weak before. But yeah, the wet fingers really fucks it up. Let's see if that's true. It's also the squinting thing. It gets a little nauseating. Yeah, I don't know. Maybe it's just the angle I'm using. I was doing vertical before. I don't know. Anyway, it's right here at our fingertips. Single slit diffraction. It was there all along. It's just almost hilarious that I didn't see that written in any other paper anywhere. Such a simple little trick. But again, it is curious that there's no color separation, just gray lines. Anyway, that's enough. So till next time.